Hello and welcome to the 7th video in this series, making Space Invaders with some HTML and some JavaScript. So this video then we're going to make the player actually move when we press the keys, and we're going to restrict the player's movement to the gameplay area. So the first thing I'm going to do then is go into the code and open up defs.js, and we're going to add in a constant that allows us to specify for each key press how many pixels the player moves in the direction that we press. I'm going to make, inside the game settings, I'm going to make a new constant, and I'm going to call that constant player move step. That can have a value of 8 pixels that will move each time we press the key to move the player. To get the player to move, we'll add a function into our player class. Remember, we're extending the sprite class, and we're going to add a simple function that's going to be called move. This function takes in an x and a y, which will actually be the direction. So 1 would be in the plus x direction, minus 1 for x would be in the minus x direction, and the same for y. The first thing to do is calculate the actual number of pixels we're going to move in each direction. And to do that, I'm going to make a couple of new variables, x step and y step, which are the move step we've just defined multiplied by the x. Just a quick word on the code. I slipped back into old JavaScript habits in a couple of videos, and I actually used var instead of let. These days I prefer to use let so I can keep control of the scoping of my variables. You'll notice if you're looking at the code on GitHub, I've made a couple of replacements already to use let instead of var. I'll try to keep myself properly disciplined and up to date from now on in the series and use let as I should be using it. Anyway, we have our x step and our y step. And the thing to do now is just to increment our position with the step that we've calculated. And this is all we need to do then to move the player. The next thing to do is to go into main.js. We're going to remove those timeouts we set at the end of the last video that are inside the init, because we don't need those anymore. That was just for demonstration. And now I'm going to remove all of the logging of the key presses inside the document ready function. And in here, I'm going to add in the call to move our player. So in the case of up, I won't be moving either plus or minus in the x direction, but I'll be moving in the minus y direction. So y will be tending towards 0 or even below 0. I'll just add the rest of these in and modify them for the down, left and right. And now we're set up to actually move our players. So let's have a quick look at this on the web page itself. And now you can see that as I press the left key, the player is moving. Press the right key, the player is moving right, up and down. And we have our sprite moving around the screen. Now this isn't the most efficient way of doing movement with pressing the keys. There are, if you look at some game frameworks, some slightly better ways and smoother ways of doing it. But for our purposes, for a learning course, just beginning getting going with HTML and JavaScript, it's more than enough. If I move the player down, you'll see that it goes outside the playing area, and we also see it outside the playing area. And there are two things I want to deal with now. The first one is I want to stop the player going over our green line. I'd like it to disappear as if it's going off screen in some way. To do that is actually really simple. I just need to make a modification to our styles.css file. And in the play area, I need to add a new property, overflow, and set the overflow, which is already default from Visual Studio Code, to hidden. If I go back now to the website and hit refresh, and now move my player down, you can see that my sprite now, because of overflow is hidden, goes hidden when it goes outside our play area div. It's already a much nicer effect than it just staying visible on the screen as it goes outside the play area. And of course this will be very applicable to the bullets and the enemies which come later on in the series. The last thing to do then is we want to restrict the player to a certain area, and I'm going to call this a bounding area. We're going to define a square or a rectangle inside our playing area here, and our player sprite will be restricted to stay inside this particular bounding square or bounding rectangle. To do that, we're going to need a rectangle, which means we're going to define a new JavaScript file. I'm going to call that rect.js, and in there I'm going to make a new class. I'm going to call this a rect class, so for a rectangle, and give it a constructor. The constructor will have an x and a y, so its position, and then a width and a height. So give it two properties, one its origin, which will be a point, and then a size, which will be its width and its height. And importantly, I'm going to give it something called a max, which is its bottom right-hand corner effectively. This will also be a point. And this point will be the origin of our rectangle, x, plus its width to give it its maximum x, and its origin, y, plus its height to give its maximum y. Fairly simple stuff to understand. I want to give it some other functions as well, which we'll need later on. So one of those will be an update function to update its particular coordinates. And here I'm saying that the origin will now become the new x and y, and that the max then get reset again, just as in the constructor, to add the width and the height on to set the x and y. And I could actually maybe make a single function that does this setting of the max in both the constructor and the update, but I'll leave it separate for now. I want to be able to shift my rectangle as well by a certain amount in either direction. So with this line here, I can just call update with the amount I want to shift in the x and y, add that to the origin, and then I'll be recalculating the max x and y inside the update function. And now two important functions that I'm going to use to detect whether a given x or a given y are within the x and y range of the coordinates of the rectangle, and they'll be used to know whether a point we have is inside a given rectangle. So the first one will be called outside horizontal. And here we can just put in some simple logic to say if our x is less than our origin x or bigger than our max x, then we are outside the x values of this rectangle, so return true, otherwise we'll return false. And we can copy and paste that and use it for outside vertical. And here there's probably an opportunity as well, if we were being really efficient, to combine these into a singular function, but I think it's, for beginning, certainly more explainable and understandable like this. But we now have in our rect class two functions which tell us whether a given coordinate or given point in x and y is outside the horizontal or vertical, and we can use that then to then say whether a particular point on the game board is outside a rectangle or not. So what's remaining then is to go into the player class, and the first thing to do is to add a new argument, and that argument will then be a boundary rectangle. And that will be a rect object that specifies the limiting boundary for our player sprite. What we'll do there in the constructor is we'll set our boundary rectangle equal to the one that we've been given, but then we'll shift it by a ranker shift so that the center point of our player actually is the detection point for whether we're outside or inside our boundary rectangle. And the final thing we need to do then in this case is add some logic to the new move function to restrict the movement to make sure we don't go outside the boundary rectangle. So in the case of the x, we say that if we are with the x step plus our current x position, if we go outside the horizontal of our boundary rectangle, then we'll limit x step to 0, so we can't move any further in either x direction. And we can do exactly the same then also for the y direction. And this has the effect then of limiting the movement to our boundary rectangle. The one more thing we need to do, of course, is add our rect.js to index.html. Otherwise the file won't be loaded. And then inside main.js, I'm going to hard code in a new rectangle inside the constructor for our player just after the asset here. And this new rectangle then is at 40 by 40, and then is the play area width -80 and the height -80. So let's have a look at how that looks then on the actual web browser. And I've just flicked back into the rect class because I've realized I've made an error there. I've forgotten to make a new point object here. So I'll just go back into, which caused me a small error. So I'm just going to go back then into the browser and have another go at that. And here we are refreshed then in the browser. No errors this time, which I got briefly when I did the first flick to the browser. And now I'm going to try and move my player and see if my player goes or remains inside the play area. And here you can see that the movement stops, being restricted inside our rectangle, which is our invisible rectangle, our bounding box, which starts at 40 by 40 and goes to the size height minus 80 and width minus 80 to give a nice realistic looking boundary for our ship to be able to play in. Okay then, so hopefully that's made a lot of sense, this video. It was, after the last couple of videos, not so complicated, I hope. Just restricting, getting the player moving and restricting the player's movement. So good, then in the next few videos we can start adding on our bullets and enemies and things like that. Any questions, as usual, please pop a comment below the video or anything. Otherwise, thanks very much for watching and see you in the next one.